line integrals. That's what we're going to do. We're going to do line integrals of vector fields. Okay, so I really need some visuals here, but let me just say I have some vector field x hat plus y hat, which is just completely made up and doesn't even have the right units and everything's fine. And I want to integrate from some point A to some point B of f.dl. Okay, let me just show you. I printed out a picture of this particular vector field. Okay, and this is point A, and that's point B. And I'm going to integrate along that path. So this says that, imagine what this says. If I'm right here, then I have, that's my origin. I have x equals 0, y equals 0. So x, I have the vector in 2 dimensions. I'm really going to do 3 dimensions later. So this would be the vector 0, x hat, 0, y hat, which is a 0 vector. That's fine. As I move this way along the x-axis and my x value increases, then I get more and more components in the x direction and also in the negative x direction. The same is true in the y direction here. So right here, as I move this way, I'm increasing in both the x and the y components, and so my vectors get longer. So this is just some vector field. It doesn't really matter what it is. Now what I want to do is to integrate f.dl along this path from A to B. I'm actually going to do it 2 ways. I'm going to do it analytically, and then I'm going to do it numerically in Python. Let's just look at this point A. Let me write this down. Point A is going to be x equals -2, y is -4, and then B is the point x is 2, y is 0. And yeah, you actually can make these vector plots in Python. You can't make them in Web v Python GlowScript. Well, you can't make them easily. But they're not actually too difficult to make in Python with matplotlib, and I will show you how to do that later, but not today. So I'm just going to show you how to integrate this line integral and then do it in Python. I have another example of another field I might do, but what I want to do is to do it this way and then take a different path. And this is one way. If I get the line integral that does not depend on the path, then it would be a conservative field. And so I'm going to show you 2 different paths. That's my goal. And I'm going to do both those in Python and analytically. But I'm going to first do this analytically on paper. I'm trying to think right now. So imagine what this would be like. Imagine this is some force field, and I want to find the work done by this field. So that would be the integral of f.dl. Okay, that just is an example. Okay, so let's go over here. So here's my vector field, f equals x hat, y hat, and I want to find the integral, I'm calling it I, from a to b of f.dl. The first thing I need is my dl vector. Okay, so if I move a little piece, what does that vector look like? In Cartesian coordinates, I'm going to say dl is dx x hat plus dy y hat. Now, you may say, hey, but that's not in the same direction as the path because the path's not at a 45-degree angle. That's what I would think. But that's true, but this is an infinitesimally small piece. And really, the direction of the path we're going to take account in the limits of integration. Okay, and we can figure out that path in a different way. So now all I have to do is take this force and dot it with this product, this thing right here. This is literally the dot product. So I can say f dot dl. To do the dot product, I take the x component of this times the x component of that. So it's going to be x dx plus the y component of this times the y component of that plus y dy. So now my integral becomes I is the integral from a to b of this x dx plus y dy. And this a to b is kind of generic, and that's fine for right now. But let's just break this into 2 integrals because it's a sum. So I can write this as the integral from a to b of x dx plus the integral from a to b y dy. Now this is actually pretty nice because this only depends on x, this only depends on y. So I can do those integrals. And it doesn't matter what the y components are right here, right, for my limits of integration. I only care about the x. So I can write this as the integral from x equals, what was point A, -2 to x equals 2 of x dx plus the integral from y equals -4 to y equals 0, y dy. And if I integrate those, I get x squared over 2 from -2 to 2 plus y squared over 2 from -4 to y to 0. Okay, so this is going to be, I'm going to write this out. It's going to be 2 squared, which is 4, divided by 2. 2 squared divided 4, so that's going to be 2, minus -2 squared, which is 4, divided by 2, which is also 2, plus 0 squared, which is 0, minus -4 squared is 16, divided by 2 is 8, so I get -8. So the answer is -8. That's that. Okay. I think I want to do this exact same integral in Python. I'm going to do the exact same path. Yeah. And so in that case, let's just think about what we would do. So in Python, how would I do this numerically? Numerically, what I'm going to do is to break this into small steps. So let me just draw my my points here. So I start here, and I end right there. And I want to break this into a piece. I'll put it like that. Piece, piece, piece. So that's 1, 2, 3, 4, 5 pieces. So during each one of these, I can actually find DL as a vector. It's going to be from there to there. That's DL. And what I can also do is to calculate F using the XY coordinate right here. So there is some value of F. Let's see, it'd be like maybe that. So that's DL. That's F. And then I can say this. DI equals F dot DL. And that means that over this short path, if I assume that the field is constant, I can do F dot DL and find out what that is here. I don't have to integrate. It's just a step. And then after that, I do it again. I recalculate the vector field at this point, and I do it F dot DL for that path, F dot DL, and then I add up all those paths. So really you get I is the sum of DI. And that's what an integral is, right? I can change the number of steps and all that stuff. So that's what I'm going to do, and I'm going to do this in Python. Hopefully I get the same answer. It might not be exact because this does make the approximation that this force at the beginning of the step is the same throughout the whole step, which is not true. But as my step size gets smaller and smaller, it's kind of true. Okay, so let's jump over to Python and do this. Okay, so here I am in GlowScript v Python. I like to use this because it's just nice. The first thing I want to do is to make a plot. I want to move my point along some path. And in fact, let's just do this. I'm going to say point A is I'm going to use the vector built-in class, vector class in Python. I said that was what? -2, -4, -2, -4, 0. And then I'm going to say B is the vector, what did I say? 2, 0, 0. Yep, okay. So let's first, I want to plot these points on my graph. That's what I'm going to do first. So let's say G1 equals graph. I'm going to give it an X title of X and a Y title of Y. I want to see it, right? Y title equals Y. Let's give it a width of 400 and a height of 400. That way it'll be square. And then I want to just make these two dots. So I'm going to say FP equals G dots. Color equals color dot red. I'm just going to plot these 2 points. So FP dot plot A dot X, A dot Y. That's going to plot the X component of the vector A versus the Y component of vector A. And then I'm going to plot FP dot plot B dot X, B dot Y. And this will allow us to see what it looks like, just to make sure things are working. Okay, so there's my 1 point I think I need to make my graph. There's my other point. Okay, that's good. So there's my first point, and there's my second point up there. Okay, I'm pretty happy. Let's next do this, and this may be a little bit weird. Let's make a function. It's not weird. It's right. Let's make a function for the vector field. So I'm going to say def f, and I'm going to give it a value, an x and y value, and then I'm going to return a vector x, y, 0. So let's just test that out. So if, let's say print f of 1, 1. It should be the vector 1, 1. Let's see if that works. Object problem. Okay, so there's a problem with this. It's a JavaScript problem. If I change up to 3.0, I think it fixes it. Yeah, 1, 1. Okay, so that seems to be working. Everybody's happy, except I haven't saved this. Line integral example 1 save. Save. Now what I want to do is to break this into n steps and move from A to B. Okay, so let's do that. I don't need to print that. Let me call the vector L from A to B. That's my total vector. So let me say this. N equals 5. I'm going to do 5 steps. I'm going to make another graph. F1 equals, let's do G dots. Color equals color.blue. And then I'm going to say L equals B minus A. So it's the vector from A to B. What I want to find is my DL. What's my step size? So DL is going to be equal to L divided by N. So I don't want to go the whole way. I want to go just N of the ways. And is that wrong? If I have N steps, let's say I have 4 steps, how many? Let's just do it and see what happens. Okay, so now what I'm going to do is to have my vector R equals A. So R is the position of where I'm at. And all I want to do is move that all the way up to point B. So let me do it as a loop. Let's try this. While R dot x is less than B dot x, right? Because I'm moving up until I get to B equals x. Then do the following. Move it. So I'm going to say R equals R plus DL. And let's plot that. F1 dot plot R dot x, R dot y. And that should be it. And that should move it all the way, I think. Let's run it. Yeah, there we go. So I said 5. 1, 2, 3, 4, 5. And it did move all the way up there, so I think we're good. Okay, so I can change this to any value, but I've moved from one piece to the next piece. Now I can calculate f at each piece and calculate f dot dl at each piece. So let's go up here, and I'm going to say I equals 0. So what I want to do is calculate di for each step, and then add it to the total I. So let's calculate, I guess then let me do that first. I'm going to say di equals f of, it's going to be dot product. Dot product's built into Python. Dot product of the vector f, which is f of r dot x, r dot y, and dl, which is just a vector. And then I'm going to say I equals I plus di, and then that's it. Move the whole way, and then I'm going to print I equals I. And it doesn't have any units. So let's see what we get. I should save it. Okay, so there's my plot. And I get negative 11. Okay, and I calculated before I got negative 8. So that's not the same. It's not crazy, though. It's negative at least. Okay, so let's see if we can make this better. That was only 5 steps. Let's do 50 steps. That's negative 8.3. You can see it's going in the right spot. Let's do 200 steps, just to really rub it in. That's a win right there. Okay, let's go back to paper, and I want to integrate along a different path and see if I get the same thing. Okay, so let's go back over here to this. So instead of integrating from A to B, I want to go, let's make a new point down here. I should do it in a color. Call that the point C. And I want to go along this path. A to C, C to B. Okay, so I'm actually just going to have two integrals. I'm going to add them together. And so this point C would be the position 2, -4. So this isn't going to be too bad because the integral is pretty easy. So let's switch over here. Okay. So I have this. I still have f vector is x hat plus y hat. I still have the dl vector is dx x hat plus dy y hat. So I is going to be the integral from a to c of f dot dl plus c to b of f dot dl. Okay, so let's go ahead and do this. I already know what this is, so I get this. A to c of x dx plus y dy plus c to b x dx plus y dy. And now I really get 4 integrals, right, because each of these is 2. So let's just break this up. I equals, this first integral is going to be x dx, and I'm going from a to c in the x direction. So a was, what did I already wrote that down? How do I have to look at that? -2 to 2. -2 to 2. This is x is -2 to x is 2. Plus the y value went from -4 to -4 of y dy. And then I get this other one, do the x, I have the integral from x dx, and then I have x is going from 2 to 2, plus the integral of y dy from -4 to 0. And I think that you can see that the answer is the same. Because if I take a look at this integral right here, if I integrate from y is -4 to y equals -4, the 2 points are the same. So whatever function I integrate, no matter what I integrate, I'm going to have that minus that. It's going to be the same thing. It has to be the same thing. So this is 0. Also for this one, x dx. If I'm going from x is 2 to x equals 2, it's a infinitesimally small, it's a 0 length integral. So this is going to be 0. So now I have x dx from -2 to 2, y dy from -4 to 4, and just a reminder, bring back the old paper. It's exactly what we had before. So I'm going to get -8. So this is going to be -8. Okay, so now let's do this in Python. And in Python, I'm gonna use my same code. I'm just gonna add another point and just do the exact same thing. Okay, so let's go back over to Python, and I'm going to even use the same program. And yes, I will give you the code down below. Okay, Python right here. Okay, so here's my Python program. I'm gonna leave it the way it is, and I'm gonna use this fp as my second path. So the first thing I'm going to do is add another point in here. I'm going to say c equals vector, what was it? 2, x equals, no, it was x equals, yeah, x equals 2, y is -4, 0. Is that right? You think I can remember this stuff? 2, -4, okay. So I'm going to leave all this the same. But what I'm going to do now is to copy it. Let's copy all this part. Okay, I'm going to copy that. And what I'm going to do, let me put a little line here so I don't forget where I stopped. So right here, I just copied it. And you should never be afraid to do things in a way that makes sense to you. It may not be the most elegant. Who cares? Okay, I'm still going to have endpoints. Now I'm going to say I'm going not from A to B. I'm going to go from A to C. So I'm just going to change that to C. That's all I did. I'm still going to have 200 points. And my starting point is still A. My starting I is 0. I'm going to reset that value to I. I already printed it out. Now I'm going to move it. I is, this is all the same. That's all the same. That's all the same. The only thing different, I'm going to plot FP plot. So I'm going to move the red dots. I'm not going to change that. And this should go to the point A. And I'm going to stop it and I'm going to print it. And let's just see what happens. I should get a different value for I because I didn't do the whole path. But all I did was change this from going from A to B to A to C. That's all. Okay. So there I went. This is my red curve now. I went from here to there and I stopped. And I got close to 0, which makes sense. I'm moving in the X direction. Okay. So now I want to do it again. So let's just copy all of this again. Copy. And I'm going to put a line just as a marker. And I want to go from C to B. So this is going to be C, and this is going to be B. Now my starting position is going to be C, right? I just went to C. And this, actually I don't even need that. I just finished it. R is already at C. And I do not want to put I equals 0. I'm still want to add this onto my previous integration. So I'm gonna do that. This is now, now this should have been C dot X. Right, so it's going to C. And this should be, now I don't want to do this, I'm moving up, right? So I'm actually want to do R dot Y is less than B dot Y, right? Because I'm moving up. That's still true, that's still true, that's still true. And I think that's all good. I think it's good. Notice that in this case, DL is going up because I took L as the vector going up and I divide that by N, so it should work. Okay, let's run it. Okay, so the path looks good, and that's the I for the first step, but the total I is the same. This whole thing works. So it doesn't matter which path I went, going from straight there, find that scroll, straight there, or this way and that way. The fun thing, you could obviously go up and over. It would be fun to give a circular path, just for fun, and show that it's the same thing. That'll be your homework. But the other thing to notice is that the two paths are identical in value, negative 8.08. And that's because, although this one has more, it has 200 points going that way and 200 points going that way, the X step size is the same as the X step size here. And the Y step size is the same as the Y step size here. You can imagine this projected onto the XY plane. And so that's why they're exactly the same. But that's a line integral. And this is a conservative field. And yes, there are other ways to test for conservative fields, and I'll get that later. I really want to focus on line integrals. I have another vector field. I might do that example. I'm not really sure if I'm going to do it or not. But if you like this, I'll do it for sure. Just let me know. And then we'll get to testing for conservative fields later. That's it.